Hello everyone, this is Harry Gill, and in this video we are going to look into the intermediate operations of the stream. These are the intermediate operations that we will look into, and I will explain each and every one of them, how they work, and we will look into an example of each of them. Let's head straight into the IntelliJ. I have already created an empty skeleton class with the main method, and the very first intermediate operation we will look into is filter. As the name suggests, the filter method is used to filter the elements of the stream. The filter method takes a predicate, and that predicate will tell whether to filter out the method or pass it on to the next operation. Let's have a look at an example, and for this I'm going to create a stream of 3 string objects, and I'm going to use the filter, and the condition that I'm going to give is that I want to filter the string whose length is greater than 2. So what this lambda will do is that when the element comes in, it will check the condition. If the condition is true, then that element is passed on to the next operation, which we will just write after this. But if this condition is not true, then it will actually block and will not pass that element to the next operation. So for our example, we have given the length of the string has to be greater than 2 to be passed on. Since filter is an intermediate operation, the return of the filter is a stream again, which means we can call any methods that can be called on a stream. We can call another intermediate operation, or we can call a terminating operation. In this case, I'm going to call for each terminating operation, and I'm going to print all the elements that I have made through the filtering condition. And now I will save and run the program. As you notice, we only print welcome and Java. The to string never got passed into the next operation because the condition that we gave, it became false. The next operation we will look into is distinct. As the name suggests, distinct will give us the distinct element of a stream, which means if a stream has a duplicate element, it's going to remove those duplicates. And distinct doesn't take any inputs. So let me write a stream using a distinct operation. So I'm going to save and run the program. As you see, we had 2 duck in the stream that was passing, but since we did a distinct on the stream, the 1 duck string got removed, and we only got the distinct elements from the stream. The next operation we will look into is skip. Skip takes a numeric argument of the type long. The functioning of skip is to essentially skip the x number of elements from the head of the stream. That x is the value that we will provide when we call the skip method. So essentially, skip removes x number of elements from the head, and the resulting stream that skip provides is the remaining of the elements of the stream. Let me write an example using this operation now. So in this example, I have a stream that's producing 10, 20, 30, 40, 50, and 60. And through the skip operation, I'm trying to skip the first 3 elements. So 10, 20, and 30 will be skipped. 40, 50, and 60 will be passed on for the for each in where I will be printing them. So now let me save and run the program. So as expected, so I see 40, 50, and 60. The first 3 elements have been skipped. The next operation is limit. Limit also takes a numeric argument of the type long. As the name suggests, limit is to limit the number of items that a stream will produce. So let me write an example and I will explain you the working. So in this example, I have 6 elements that stream will produce, and I'm only limiting the output to 4, which means as soon as the stream provides 10, 20, 30, and 40, it is going to stop producing now because I only want the first 4 elements of the stream. And these 4 elements are passed into for each where we print them out. Now let me save and run the program. And as expected, we only print the first 4 elements of the stream. Due to the nature of the way limit works, if we call a limit on an infinite stream, then the limit method will actually make that infinite stream into a finite stream. So let's see an example. So in here, I'm producing a stream from number 1, and then it will keep on incrementing it and keep on producing the numbers. So this is how we create an infinite stream. And on that infinite stream, I'm calling the limit method and giving an argument of 5. So this means that even though the infinite stream will produce an infinite number of integers, however, I only need 5 of them. So as soon as the 5 numbers are produced, the infinite stream will be stopped. So limit is one of the intermediate operation that actually has a capability of turning an infinite stream into a finite stream. So let me save and run the program. As you notice, we print number 1 through 5, and after that the stream has stopped producing the numbers. The next operation we will look into is map. The map operation takes a function as an input. So that function can be used to convert an element of one type into another type. There are use cases where we get the stream of a type of element and then we want to do the conversion to a different type. That is where the map will be used. I'm going to produce a stream of strings and call a map method. And the function that I'm going to give is that it is going to convert a string into an integer, and that integer's value will be the length of the string that is passed in. And then output of the map will go into the input of for each, and I'm going to print all the elements. And now let me save and run the program. So the resulting stream which came out of map is a stream of integer, and the value is 4, 4, 5. So these numbers corresponds to the length of the string of the elements that was coming in. The next operation we are going to look into is flatMap. The easiest way to remember what flatMap does is to divide the whole word into two parts. So the first part is flat and the second part is map. The map part is same as what we looked at the above example. The main thing to note is in this case, the function that we give in, the output of the function should be a stream. Input can be anything, but the output has to be a stream. And the flat part of it is that once we have the stream of streams, it is going to take the elements of the streams and put it at a one level up. So think of it as we have a two-dimensional array, and from the two-dimensional array, the flat bit will be converting it into a one-dimensional array. So let's see an example and then it will be much clearer. So I have created two streams. Both the streams are totally independent streams and two streams are the integer streams. And now I'm going to create a stream of streams. And on this stream, I'm going to call the flatMap. As mentioned previously, the requirement of the function that we need to give into the flatMap is that function should return back a stream. In our case, since both the elements are actually stream, we don't need to do any conversion. So we are simply returning them as is. So I'm just giving you this as an example because it's easy to understand. In the next example, we will look into more realistic use case. And now output of the flatMap is a stream. So you can use any operations that we can use on a stream. And in our case, I'm going to simply print all the elements of that stream. And now I'm going to save and run the program. So as you notice, 1, 2, 3, 4 are printed because they were in the stream that was created by flatMap. So they were in a new stream. They were pulled out from the streams that we created here and they were put into a new stream from where we printed the for each. Let me comment this out and let's have a look at a more realistic use case. I'm going to create 3 lists, and the very first list here is an empty list. Now I'm going to create a stream of lists. On this stream, I'm going to call the flatMap method. And the function that I will give into flatMap is that the input will be a list and the output has to be a stream. And the way we would convert a list into stream is by calling the stream method on the list. So once I have this, after that I'm going to simply print all the elements of the stream. And the lambda that I have given into the flatMap here, that can be converted into a method reference. And now I'm going to save and run the program. And the output that we see here, we printed goose 1 and 2. which means that the elements of the various lists that we had given, they were actually put into the one level above. And also while doing that, if there is any empty list, in our case the list called 0 doesn't have any elements, so that list is ignored. I hope the concept is clear. This is the most complex intermediate operations that I feel. If you do have any question, ask me in the comments and I'll respond back. The next intermediate operation we will look into is sorted. As the name suggests, the sorted method will sort the elements of the stream. This operation comes in two flavors. One without any arguments. The other flavor takes a comparator where we can give our custom sorting logic. So I'm going to create a stream with a bunch of integers and call the sorted operation on it, and then print all the elements of the new stream. Let me save and run the program. As you see in the output here, since we had given the integer, the elements are sorted in the natural order. Now let's say if we want to provide our own comparator, we don't want the natural ordering, or let's say there is no natural ordering. For example, a stream of the people object, we will need to tell how to sort the people, whether to sort it with their name, with their age. That will depend on our logic. So that is where the second flavor of sorted come into play. For my example, I'm still going to use the integers, but I'm going to pass a comparator that sorts the integers into the reverse order. And now I'm going to save and run the program. So as you notice here, now the integers are sorted, but now they are in the reverse order. And that's because I have asked the sorted method to sort the integers in that way. The last intermediate operation we will look into is called peek. So peek method is usually useful when you want to have a look at the elements as we process them. Until now, if we wanted to have a look at an element, like what the stream looks like, we usually call for each, and then we pass a consumer where we print the elements. But the main difference between peek and for each is that the peek will return the stream. However, for each is a terminal operation, which means as soon as for each is complete, we actually terminate the stream. So we cannot call any of the other stream operations after for each, given that for each is a terminal operation. So I'm going to write a stream of strings and I'll filter the elements based on their length. And then finally, I'm going to call the count terminal operation, which will tell me how many elements are greater than length of 2 in the given stream. I'm going to store the count into a variable and then print it. So if I'm going to run the program now, then count is going to return some value back and we will print that value. Now let's say that value we got is not what we expected, but we don't know what the stream actually contains. So in this example, it's pretty clear and straightforward that we have 3 elements. But in the real world, you can get a stream as an input to your method. And in that method, you don't have a way to look into the stream. So that is where the peek comes into play. So peek is mainly used for debugging. If the result is not what you expect, you can always put a peek and see what the stream contains. And based on that, you can fix your program if there is any issue. So I am going to simply call the peek method and then print the elements. And since it's an intermediate operation, we didn't end the stream. We simply pass the same stream into the filter method, which does its logic. And now I'm going to save and run the program. So as you see, we printed individual elements of the stream, and then finally we printed the count. And if there is any problem, you could figure out by looking at the elements of the stream. So these are the all intermediate operation you need to know for the exam and for most of your real world programs as well. Now that we have covered on how to create the stream, what various intermediate operations are, and what are the different terminal operations, now you have all the information to put a streaming pipeline together. In the future videos of this series, we will look into the streams of primitives. If you have liked this video, please hit the subscribe button and the bell icon so that when I upload my future videos, you get a notification. Until next time, bye-bye.